All right, we've got our last section of Unit 5 here to talk about. And what we are doing here is we are comparing linear functions to exponential functions. So today is all about looking at their properties and being able to identify if it's linear or exponential from all sorts of formats. Now, what I want to begin with is I want to start with two graphs on one coordinate plane. All right, so will you add to your table here? We are going to start with 0 in place of the month, and we're just going to go up by ones. So take a moment to go ahead and complete the month column, just 0, 1, 2, and so forth. So we'll end here at 12. Now, option 1 and option 2. Above option 1, will you write the word double? We're going to double everything in a moment. And then let me do a different color here. Option 2, we are just going to add, let's say this is money. Let's say we're going to add $100 every time. Okay. Option 1, at month 0, let's say we're going to start off with $1, okay? And then on option 2, we're going to start out with $500. So we are going to complete the columns by doubling the middle column and adding 100 to the one on the end. So the doubling is multiplying by 2. So I'm going to take 1, multiply by 2, I get 2. Take 2 and double it, or multiply by 2. That's going to be a 4. 4 times 2 is 8. 8 times 2 is 16. And then just keep going on option 1. And then actually, let me jump over to option 2 and then give you a chance to work. So option 2, we're just adding 100. So the next one would be 600. 700, 800, and so forth. So I want you to pause the video and complete your 2 columns and then come back and we'll move on to the graph. Okay, take a moment and see if you match what I have here. So before we go to the graph, let's take our 2 columns and let's let's create these equations. So I want you to think linear and exponential here. I am doubling in option 1 and I'm adding the same amount in option 2. So which one do you think is linear and which one is exponential? Well, linear is that steady increase. It's going up the same amount every time. So when I add $100 every month, that's really like your slope. So my purple column here is my linear function, but doubling is going to be my exponential. It's going to grow really fast. So let's write the equation for the linear. So think y equals mx plus b. So if it's going up by 100 every month, that's like your rise over run your slope. So my equation would start with y equals 100x. And then remember your starting point. Where did we begin? Well, we started at 500. So that would be our equation for the linear column. Now on our exponential, so remember we're going to do y equals a times b to the x power. So a is our starting point. So I'm going to go ahead and write 1 down. And then the growth factor, it's doubling. So doubling is a 2 and to the power of x. Now, it might very well be written more like this without the 1, but I think the 1 kind of reinforces our starting point. Okay, I want to take a few moments and graph this. So I've already given you the scale. So we've got the number of months down here. Okay, 1 up to 13, going by ones. And notice in our month column, we're only going up to 12, so we're good. So the doubling, or I'm sorry, not the doubling, the Y column is, we have money going on here. So I'm just going to call this total, I guess, total amount. Okay, and of course we're working with dollars here. So let's go ahead and graph. Now doubling. So the month is going to be your X. Right now I'm just looking at doubling. That's going to be my Y. So look at your scale on your Y. It goes by 500. So my dots are going to be pretty close together for a while. So 0, 1, I mean, I'm going to just barely be above the X-axis. 1, 2, just a teeny bit more because this is a span of 500. 2, 4. Here's what I'm going to do. I'm going to jump ahead to number 9. 9, 5, 12 to give me some perspective. So 9, 5, 12 is about right here. All of the numbers between month 2 and month 9 have to range between 4 and the 5, 12. So it's going to gradually go up a little. So let me go back to 3. 3 is 8, so I'm just going to try to make them a little bit higher than the last dot. 4 is 16, 5, 32, 6, 64, 7, 128, 8 is 256, so I can maybe just go a little bit higher here. There's my 9, 10 is 1,024, so just a little bit above 1,000, so now it's starting to really grow. 11 is 2,048, so a little bit above 2,000. And then 12 is a little bit above 4,000. So way up here. All right, so remember, we kind of are hovering here. And then we jump really fast. Whoops. All right. Okay, linear. So I expect a line. So 1, 500. Not 1, I need to look at the month. 0, 500. 1, 600, and I'm going to jump ahead again. See how 5 is at 1,000, and that's my next mark on the Y. So I'm going to go like this. I'm going to go ahead and just do that, and then the rest should make a line. So 2, let's see, 1 is at 600, a little bit higher. 2 is at 700. 3 is at 800, 900, so that's kind of straight. I mean, we're estimating this. So let's jump ahead. Do we have 1,500 on here? Yeah, out at 10. So 10, 1,500. So I know these are going to make a line. So I know it's going to be, gradually increasing. So that's what I'm going to just kind of graph those two. I will jump ahead to 12, 1,700. It's about right here. So my line, is going to be right here, okay? Okay, so what I want you to see is sometimes having a linear pattern is more beneficial than an exponential, but it really depends on the point in time. So in the end, you probably want the exponential function. Like if this was your bank account, I'm pretty sure that I'm okay in months 0 through 11 being lower than the linear because look where we end. So it kind of depends on your what you're trying to do. Do you need a short-term item? Well, linear might be better. If let's say it's an investment and it's long-term, well, you're going to be better off having an exponential growth if you could choose that. Okay, so I just want you to see the two things, and I also want you to take away the equation we wrote because we're going to look at all of those next. Okay, let's go on to the next page. Okay, let's talk about some differences here between linear and exponential. All right, so linear, number one, linear means line, so we will make a line when we graph it. Exponential is more of a curve. It doesn't really have a good name to it. We'll just call it a curve. Linear, we added or subtracted to increase or decrease. So our pattern is in adding or subtracting the same amount. Exponential will be multiplying or dividing. We usually write it as multiplying. I'm going to put here /dividing because if you're trying to determine a pattern, you might be able to see it's dividing by the same number. Let's do our format, y equals mx plus b, kind of our slope-intercept format. And then our equation on exponential is y equals a times b to the x. Okay, here's some examples. So let's say we have, let me write one like this, y equals 5 plus 1.25x. Now, it's kind of flipped around, but I still see the adding or subtracting of the 1.25 every single time. You know, maybe it's 1/2 x plus 1. There's our traditional slope-intercept, that type of thing. Exponential. So let's take our linear equation. The starting point is 5, so it would start with 5. And then maybe it's multiplying by 1.25 every time, okay? The second one, if I were to convert it to exponential, the starting point is 1, so I don't have to write 1, but I could. But it's a 1/2 to the x power, okay? So that's kind of like it's going up by, actually it's going down, it's more of like a half-life. So those are some things, if we're trying to identify linear or exponential from an equation, these are the aspects that I'm going to search for. So I would like you to take a look at these 6 items down here. I want you to decide, are they linear or exponential? So if you want to put L or E next to them, that's fine. But pause the video and run through these and come back and let's check over it. Okay, first one is exponential because it's the, actually I'm looking for the x power. Exponential again, it's raised to the x power. The third one's linear. This is our, like our slope and our y-intercept. This is linear too because it's being multiplied by x. It's not being raised to the x power. Linear right here. And exponential, raised to the x. Okay? All right, let's move on to if we have a little situation that is being described to us, is it linear or exponential? The number of bees in a colony doubles each day. Doubles. So that's kind of like the example we had on the very front. This is exponential. Doubling will get very large after that. Letter B, you earn $8 per hour at your job. So it's a steady increase of $8 every hour, linear. So 8 would be like your slope. The antique car appreciates 4.5% each year. Okay. Typically percentages are exponential. So it's going up at even though it's going up at the same amount per year, it's going up at a percentage, which is going to cause it to go up rapidly after a few years. So this is exponential. Last one, your parents give you $50 for your birthday and $5 each week after that for a year. So this is a linear pattern again, it's steadily increasing. Okay, so that's more of a situational approach. Lastly, let's look at tables. So when we are deciding if a table is linear or exponential, we want to look at the pattern. So linear goes up at a constant rate of change. Like we had this, it goes up $8 per hour. So it's like plus 8, plus 8, plus 8. Doubling, though, would be times 2 times 2. So we really want to focus on this. Is it adding or subtracting? That's the linear pattern. Multiplying or dividing is more exponential. Okay. Now, I can see over here, these are all going up by 1, so I don't really need to compare these to the y values. But when I look at this, let's see, 7, I'm going to come back to the decimal, 7 to 14, 14 to 28. Okay, this is multiplying by 2. 7 times 2 is 14. 14 times 2 is 28. Now I can go back to 3.5. I can see more clearly it's times 2. Multiplying by 2, this is doubling. This is exponential. Okay, pattern going up by 1 on the x's. So 3 to 6, 6 to 9, 9 to 12. That is going up by adding 3 every time, linear. Okay. Now, this one, what I might start with is when I look from 64 to 80, what is that? That's an increase of 16. So you could even do 80 minus 64. So is it going up by 16? Well, no, because 80 to 100 is not going up by 16. So is it multiplying? So I can't really tell. So I'm going to take the second number divided by the one above it. Okay, so let's maybe start with 64 divided by 51.2. So 64 divided by 51.2 is 1.25. So that means I can reverse that and say 51.2 times 1.25 gives me 64. So let's keep checking it. Let me fix that. 5. So if I do 64 times 1.25, I get 80. Okay, it looks like that's the pattern. So 80 times 1.25, I get 100. So let's skip ahead. 156.25 times 1.25 is 195.31. So I am multiplying by 1.25. That is an exponential pattern. Okay, I want you to wrap this up with D, E, and F. I want you to tell me, or pause the video and write down, is it linear or exponential? Okay, let's see, 25, 50, 75. All right, we are going up by adding 25. This is a linear. Letter E is a straight line, linear. F is a curve. This is your exponential.